Dear colleagues, I'm really glad that you're watching this video. The topic of our research is the open source based approach for search of development teams. The research paper and this presentation were prepared by me and my mentor Nadezhda Yarushkina. We both represent Ulyanov State Technical University. So I would like to transfer myself to the slide number 1, and here I would like to enlist some terminology that I will frequently use during my presentation. The term number 1 is a project team. It assumes that complex IT software could be implemented by a well-coordinated team. So project team is such a team, which main valuables are not only professional skills but good experienced relations between its members. The number 2 is repository. It's a set of artifacts. In the development world, they are code, documentation, SQL procedures, and something like that. Contributors are actors of the process. They are developers who bring in new ideas into project while committing mentioned early artifacts. And the last but not the least, open source. In this context, it's a variety of repositories that can be found on the GitHub, for example. So here comes the problem of our research. It's the lack of professional software developers and the problem of hiring new ones for the company. The problem arises because IT sphere grows rapidly and there are less specialists graduated annually than required. Especially this problem occurs in the regions. Another problem here is a kind of migration. Some engineers leave their regions for the better place of work or going to work remotely, for the foreign companies, for example. The proofs of these statements are: fact number 1. Some research companies like Gartner or IDC or even development societies like Crusoft make their own researches and reveal this problem. The fact number 2. There are plenty of vacancies for experienced engineers on the market. They are open for a long time because there are no occupants for these vacancies. However, they are free and the salary is quite high, but no occupants. That's a fact. The fact number 3. Many companies try to get new specialists while opening their own in-house programming schools and academies and ready to teach people who are even absolutely new in programming. That's how the situation going worse. The fact number 4. Big companies like VK, Yandex, Avito actively participate in regional life of IT sector and they even organize regional IT events. Their hope here is to pull developers out of regions because their capital suffers the same problem, the shortage of good developers. But the companies found the solution for the problem. They decided to allow the employees work remotely. That opened, of course, new hiring perspectives and a road to the global employee market. Now we can hire worldwide. But the remote approach has some advantages, of course. Employees are more efficient because they do not spend much time on the office affairs and more carefully plan their working schedule. Hiring activities now are no more local, they're worldwide. And it's easy to hold the remote employees because of their salary. It can be set up higher than the average salary in the region where employee actually lives. There are several good examples of absolutely remote teams in our country. For example, Skyeng. They develop online school for English learning and they are remote. Another good example is Evil Martin's development group. These people stay, for example, behind eBay and other widely known solutions in the world, and they work perfectly remote. But when you would like to transfer your company onto new rails, your HR management will come to you and ask how, where and whom to hire. But the modern trends now dictate their terms. They require teams. Because software solutions become more complex and it's crucial for HR to get a good team for developing the project. But team actually means not only skills, the relations between its members and their experience of working together are vital as well. Thus, finding a good development team is a complex task. The solution that we would like to propose for such new teams is based on using the open source services like GitHub. But we use not actually the service itself, but the data inside. GitHub contains more than 100 million of repositories and more than 37 million developers are registered there. Frankly speaking, it's a kind of social network for developers. And the data there is absolutely open and can be used for their research. The entire goal of the research is to design new algorithms that will help to find a solid development team based on open data. One of these algorithms assumes the search within a single repository. On the contrary, another one is based on the person-based search. But it will be described in the very conclusion of the article presentation because it's under development now. The team search is not easy even within a single repository, because according to the nature of open repositories, there are usually a majority of developers who does not belong to the main team, core team, and they are just side contributors who are interested in the project's development for their own purpose. GitHub provides us with a rich API, so we can use all the data that stores the service itself. We can use repository data like contributors, the information about development history, its commits, and so on. We would like to propose to search the main team via clustering. For this purpose, we used k-means algorithm because its ability to pretune the number of clusters is quite vital for our case. To boil the results of clustering, we decided to provide two clustering procedures for the repository data. Each of them is based on its own metrics, and the results are awesome because due to this double-layered clustering we have more accurate results, and the algorithm performs really well. The first procedure is based on development metrics, and there are a number of insertions and deletions into the repository files that made by every developer. That means more insertions and deletions a developer did into a variety of files, the more we are sure that this developer belongs to the core team. The second procedure is based on management metrics because some of developers are managers, they are leaders of the project, and they need to carefully plan the development process, set up the tasks for the rest of the team, and they are actually responsible for new releases of the applications. That's why we have decided to add second clustering procedure for them. And finally, we can underscore choosing clusters. The cluster number 1 is a contributor. It's a project participant who makes a relatively small number of contributions to the project. The cluster number 2 is a participant, the specialist who time to time takes part in this project development, its improvement. The cluster number 3, a prospective member of the team. These developers are quite involved in the project's life and really frequently do their changes. And of course, the last but not the least, the main one is the main developer, a specialist who makes the greatest contributions to the project. This slide describes the repositories we choose for their experiment. The repository number 1 is a ClickHouse, a column-oriented database made by Yonex itself. The dataset contains more than 300 contributors who did more than 30,000 commits. The repository number 2 represents E2, the popular PHP framework for web applications development. In this case, we have about 1,000 contributors who did more than 20,000 commits to the repository. Number 3 is a group of repositories, Experimentation and Catalyst. There are machine learning libraries which popularity is growing up day by day. They are not large as previous ones, of course, but anyway the dataset contains 50 developers and nearly 2,000 commits. And repository number 4 belongs to mentioned early group of Evil Martin developers that in these repositories are frequently used by Ruby and front-end developers. The dataset here contains the society of 400 developers and nearly 20,000 commits overall. Here comes the experimental part of our project, our algorithm. This picture shows an example of clustering analysis made for ClickHouse repository. Here you can see the distribution of contributors based on development metrics. The figure shows 4 clusters. The orange one describes developers who belong to the main team. They contribute most of all. The purple circles the prospective team members. The most numerous clusters, of course, are project participants and just raw contributors. There are a majority of them within the development process. On this slide, we have management management clustering. This figure shows the distribution of contributors. However, this time the number of them is less than in previous example because, as I said before, not every developer creates tasks and manages the project and launches new releases. These slides describe the results of our algorithm work. The accuracy of algorithm is based on the expert assessment. The experts are lead developers of mentioned projects, so they personally know the team. The clustering helped to find almost 65 of projects' main developers, and the matches between experts' opinion and the algorithm results are underscored by the gray color in these tables. To conclude my presentation, I would like to tell you about further research which will be dedicated to developments of person-based search algorithm. This algo will help us to form up a social tree of developers and their repositories first. Then, with the help of this tree, we will be able to indicate the experienced relation between developers, who, when, developed the same projects and what time it was earlier. That's why we would be able to compile a rating of the proposed teams by the algorithm and use this rating for looking up for our own development team for the project. I thank you for your attention and hope to see you at the conference online and respond your questions in person. Thank you very much. Bye.